Hello students, today we will solve one more question in this class, and the question states that a slab of material of dielectric constant K has the same area as the plates of a parallel plate capacitor but has a thickness of 3 by 4 D, where D is the separation of the plates. How is the capacitance changed when the slab is inserted between the plates? Understanding the question, they are stating that we have a parallel plate capacitor. We have a parallel plate capacitor. This PPC is having a distance d between them, and can store some amount of energy in it, and that energy is given by C equals to Q upon V. Right? Now we got a dielectric. The dielectric constant for this dielectric material is K, and this dielectric have a thickness of 3 upon 4 D. So this dielectric will come here like this. This is dielectric, okay, will come like this, and its thickness T is 3 upon 4 times the D. After inserting this dielectric, they are asking us what is its capacitance. C of D is how much? That is what we need to calculate. Okay, these are the given information. Now we will see the solution. The given information is material with the dielectric constant K. Material A equals to A of parallel plate. Area, here A states area. Area of the dielectric material is equal to the area of parallel plate capacitors. Now thickness of the material, or the thickness of the dielectric slab, thickness of the dielectric slab is 3 by 4 times D. Here D is the separation between the plates of parallel plate capacitor. Change in capacitance when slab of material inserted into the parallel plate is the question. Is the question asked by us? Like, is the question they have asked us, which we need to solve, should be solved by us. Okay, now we know electric field between the plates when there is no dielectric, and potential difference is V naught. It is given as E naught equals to V naught by D. Electric field in the absence of dielectric. Electric field between parallel plate capacitor when dielectric is not there. It is given as E naught equals to V naught upon D. D is the distance between the two parallel plate capacitors. When dielectric is inserted, in case we have inserted the dielectric, what will be the changes that we are going to observe here is electric field will become E naught upon K. It will get influenced by the dielectric constant. It will become 1 by K times the electric field without dielectrics. Then potential difference will be, now from the help of this equation, equation 1 and equation 2, we can find the difference in potential. Okay, so E is E naught by K, E naught is V naught by D. Okay, substituting over here, we will get the potential equals to E naught into 1 by 4 times the D plus E naught by K 3 by 4 times the D. This is for parallel plate capacitor, parallel plate capacitor, and this one is for parallel plate capacitor plus dielectric media plus dielectric media. Why do we need to find V and E? What's the concept? See over here, I have written this formula, C equals to Q upon V, or energy is given by half of CV square. I'll write energy as U, otherwise it will be confusing between the electric field and the energy. Okay, energy is given as half CV square. That's why we have to find the voltage. To find either the energy or the capacitance, it is extremely necessary for us to know the other components like voltage, charge. Okay, so after solving it, we find that voltage after inserting dielectric comes around to be V naught into K plus 3 by 4K. Voltage after introducing dielectric material. Dielectric material. Now the potential difference decreases by a factor of 3 plus K upon 4K. It decreases. V decreases by a factor of K plus 3 upon 4K. How can we say it is decreasing? Now let us try to take the value of K. Value of K as 1, K as 2, we will understand. Now if dielectric constant have value of 1, this factor will become 1 plus 3 upon 4. That is 4 by 4 and that is 1. So it will remain same. Now dielectric constant is 2. In that case 2 plus 3 upon 4 into 2. That is 5 upon 8. What is the value for 5 upon 8? It will come around 6.6, not 6 point, 0.6 and 1.61, something like that, which is smaller than 1. If K equals to 3, we will solve one more question to understand that this is decreasing. It will be like 3 plus 3 upon 4 into 3. That will be 6 upon 12, and it is 1 by 2, and that is 0.5, further decreased. As the dielectric constant increases, this factor will show a decreasing trend, and hence the potential will also decrease. Now we will try to find the capacitance. The capacitance thus increases. Why capacitance thus increases? We have seen the formula, C equals to Q upon V. In case Q increases, C will increase. In case V increases, C will decrease. Why? C is directly proportional to the charge carried by the system, and C is inversely proportional to the voltage carried by the system. Okay, so substituting the value of V from here in this particular formula, the charge will remain unaltered in case of introducing dielectric in it, and even when the dielectric is not introduced, charge will remain same. So I'll write over here, charge will remain same before and after introducing the dielectrics. Okay, so charge will remain same, and V's value we will get from this particular equation over here, and then we will solve it further. To get the new capacitance equals to 4K by K plus 3 times the old capacitor. C is capacitance after introducing dielectric, and C node is initial capacitance. Initial capacitance. Okay, now this capacitance after adding a dielectric is increased by a factor of 4k upon k plus 3. This plays an extremely important role in the capacitance, as we have already read in the concept when we were learning about capacitance. But once again I will remind, as we introduce dielectrics in capacitors, it increases their capacitance. Capacitance is increased. We can reach this capacitance even at lower voltages, or lower potentials. So isn't it helpful? Yes, it is efficient. It is efficient. Once we introduce a dielectric in the capacitors, capacitance of that capacitor increases and the potential decreases, giving us more efficient capacitors to store energies. So this is also a application as well as a numerical based question, a very beautiful and important question. Hope you understood this. We'll meet in the next class with a new topic or a new question. Till the time, take care, study well, have a good day. Bye bye.